Today's topic is solving rational inequalities. Tomorrow we are going to look at graphing rational inequalities, but today I do want to look at the graph of the first inequality because I think understanding the graph will help you to understand why the algebraic process works the way that it does. So here I have number 1 graphed. The left side, 8 divided by x plus 5, is the orange function, and the right side, y equals 4, is the purple function. So this inequality is asking us where the orange function is less than or equal to the purple function. Looking at our graph, we can see that occurs here on the left. The orange is less than the purple, and it continues all the way to this vertical asymptote. Jumping to the other side of the asymptote, the orange function is now greater than the purple function. But then after this intersection point, the orange function is again less than the purple function. So there are a couple of key values on this graph for finding our inequality: the vertical asymptote and the intersection point. You can see those establish the boundaries for possible solution sets, possible intervals. To translate this to our algebraic process, I've written here some steps for solving rational inequalities. So the first thing we're going to want to do is find our critical numbers. Those critical numbers are the vertical asymptotes and the intersection points. The next thing that we want to do is draw a number line that represents our x-axis, our x values, and then finally we are going to test an x value in each interval to see whether it satisfies the inequality. So let's go ahead and take a look at the first one algebraically. So first we are going to be looking for our critical numbers, which I will write as Cn. Our first type of critical number is where the function is undefined because we are looking for vertical asymptotes. So this is going to occur where x plus 5 equals 0, which is when x equals negative 5. So our first critical point here is going to be x equals negative 5. The other type of critical number is our intersection point. So I'll say IP here. And we can find intersection points by simply setting the left side of the inequality equal to the right side of the inequality. We saw this last week when we did solving rational equations. So here we have 8 divided by x plus 5 equal to 4. Multiply everything by our common denominator of x plus 5. So that divides out and gives us 8 is equal to, and then here we have 4x plus 20. So now we'll subtract our 20, solve this algebraically to find that x equals negative 3 is an intersection point. So x equals negative 5 and x equals negative 3 are the critical numbers we'll work with. Our next step, second, is to draw a number line. And we'll put these critical numbers on our number line, negative 5 and negative 3. I like to show what type of critical number these are. So our undefined values, I put a vertical asymptote, and the intersection point, x equals negative 3, I'm going to actually put a point there. And because this is less than or equal, it's going to be a solid dot. And then finally we want to test some values, x values within each of these three intervals. So we'll do negative 6 over here, negative 4 here. We could do negative 2, but I want to choose something that's convenient. So I'm going to pick 3 because 3 plus 5 is 8, and 8 divided by 8 will be easy to solve. So I'm going to put a 3 there. So if x equals negative 6, we have 8 divided by negative 6 plus 5. So is less than or equal to 4. Negative 6 plus 5 is negative 1. So 8 divided by negative 1 is going to be negative 8. It's less than or equal to 4. This works out. So I'll put a check mark up here. Next, when x equals negative 4, we have 8 divided by negative 4 plus 5 is less than or equal to 4. So negative 4 plus 5 is 1. 8 divided by 1 is going to be 8 is less than or equal to 4. So that one does not work out. Not a true statement. And finally, if x equals 3, 5 is less than or equal to 4. 3 plus 5 is 8, so 8 divided by 8 will give us 1 is less than or equal to 4. And that is true, so this last interval checks out. So the last thing we need to do here is write our solution set. We have negative infinity to negative 6. And that negative, oh, my mistake. And this is a common error, so I'm going to leave this in the video so you can see this. You're actually using your critical numbers, not the test points. So I want you to see that I made that mistake so you can avoid making it as well. So here negative infinity to negative 5. That negative 5 is undefined, so it's not included. Or we can have values to the right here, and that's to the right of negative 3. That is included because it's less than or equal to, so negative 3 to infinity. That will be our answer. For number 2, we're going to follow this same process. So first we are looking for our critical numbers. Our first type of critical number is where the function is undefined. So that happens where x equals 0 and where x minus 6 equals 0. So that's where x equals 6. So our first two critical numbers, go ahead and write here. X equals 0 and 6. Next is our intersection points. So we will just make this an equation. X minus 2 divided by x equals x minus 4 divided by x minus 6. To clear out those denominators, we need an x and an x minus 6. So we'll multiply that through. Our x's divide out, and we have x minus 2 times x minus 6 is equal to, these x minus 6's divide out, so x times x minus 4. So x squared minus 8x plus 12 equals x squared minus 4x. Solving this algebraically, our x squareds will subtract out to 0. I'll add 8x to both sides, so 12 equals 4x, or 3 equals x. So our other critical number is going to be a 3, positive 3. The next step here is to draw our number line with our critical values. So we have a 0, a 3, and a 6. Please put these in the correct order. If you write 0, 6, and then 3 on your number line, you're going to get an incorrect solution. So 0, 3, 6. The 0 and the 6 are the undefined values, so I like to put little asymptotes there. And then the x equals 3 is going to be a point, but here it's just less than, not less than or equal to, so that's going to be an open circle. So the third step, we are testing points. Because we have all even numbers here, 2, 4, and 6, I'm going to select even numbers. I think that will make the math a little easier. So negative 2, 2, 4, and 8. I already went ahead and did the work for checking these test points. stop the video and fill in those values as well so that you can see them. So let's take a look. When x is negative 2, we have 2 is less than 3/4. Is that a true statement? No. So we are going to put an x up here. When x is 2, we have 0 is less than 1/2. Is that true? Yes. So we'll put a check mark. When x equals 4, we have 1/2 is less than 0. That is not true. And finally, when x equals 8, we have 3/4 is less than 2. That is true. So we'll put a check mark there. So finally, and don't forget this step, you have to write your solution. We have this interval from 0 to 3. The 0 and the 3 are both not going to be included. So 0 to 3, open parentheses. Or from 6 to infinity, and that 6 is also not included. And that is our solution. For number 3, we're just going to follow the same process. So we'll look for our critical numbers. First, we'll look for any undefined values. So here we have 8 and 10 in our denominators. Those will never equal 0. So we have no undefined values. Second, we will look at our intersection points. So 5 plus 7x divided by 8 minus 15 plus 3x divided by 10 is equal to 2. We'll clear those denominators by multiplying by 40. 40 divided by 8 is 5. So we have 5 times 5 plus 7x. And 40 divided by 10 is 4, so minus 4 times 15 plus 3x. And that will be equal to 2 times 40, which is 80. So now solving this, we have 25 plus 35x minus 60 minus 12x equals 80. So 35x minus 12x is going to be 23x. 80 plus 60 is 140 minus 25 will leave us with 115 on the right. And then dividing 23 gives us x equals 5. So our critical numbers occur when x equals 5. Our next step is to draw our number line. With 5, our only critical number. So now we need to test some points. Well, first actually I want to indicate that this is less than, not less than or equal to. So we're going to have an open circle here. And now we'll test some points. We are going to try, let's do 0 on the left. And on the right we can do 6. So I've got my work here for the test points. And we can see where x equals 0. Negative 35 over 40 is less than 2. Is this true? Yes, because a negative number is always going to be less than a positive number. So put our check mark there, and over here when x is equal to 6, we have 103 divided by 40 is less than 2. Is that true? No, because this is going to be 2 and some fraction. So this does not work. So for our solution, we have this portion on the left from negative infinity to 5. And 5 is not included. So next we'll look at number 4. Our critical numbers, where this is undefined, y equals 0. And then where we have our intersection points, we have y plus 5 equal to 6 divided by y. So we can multiply y through to clear that denominator. Y squared plus 5y equals 6. Now we'll subtract our 6. From here we can factor y plus 6 and y minus 1 equals 0. So we're going to have some critical numbers at y equals negative 6 and y equals 1. So here we have y equals negative 6, 0, and 1. Our next step is to draw our number line. With our negative 6, 0, and 1. 0 being the undefined term. 6 and 1 will get solid points because we are looking at an inequality that is less than or equal to. Again, I have posted my work here, and you can see the points that I tested are negative 7, negative 1, 1/2, and 2. So let's see what this says about our intervals. Negative 2 is less than or equal to negative 6/7. This is true, so the interval on the left works. When y equals negative 1, 4 is less than or equal to negative 6. Not true, so we'll put our x there. When y equals 1/2, we have 5/2 is less than 12. That is true. And then when y equals 2, 7 is less than or equal to 3. That is not correct. So our final solution set is going to be here on the left from negative infinity to negative 7, and that is included because of our solid point. Or this interval here from 0 to 1. The 0 is undefined here, so we are not including that, but the 1 is included. That is our answer. On the next page, numbers 5, 6, and 7 are fairly straightforward applications of what we have just done, so I want you to go ahead and complete those on your own and come with your work shown to class. I also want you to try working through number 8 on your own before you come to class tomorrow. I will post the answer for this one right now and show you my work, however. So go ahead and pause the video, work through 5, 6, 7, and 8, and I will show you my work for 8. My work is now displayed for problem number 8. Check your answer to see if you came up with the same thing. Please come prepared to class with 5, 6, and 7 already completed and ready to discuss.